In these examples, we're multiplying monomials by binomials and trinomials. So let's start with number 20. So here we have a monomial, 6t cubed, multiplied by a binomial, t to the fifth plus 3t squared. All right, so really we're just going to use the distributive property, right? We're going to multiply the monomial times each term in the binomial. And so 6t cubed times t to the fifth, that's going to be 6t to the eighth, right? So since I have like bases, I just add the exponents using the product rule. So then 6t multiplied by 3t squared, 6 times 3 is 18, t cubed times t squared is t to the fifth. Right, so that'll be our final answer. So we always want to check to see if we can combine like terms, but remember that like terms have to have the same variable expression, meaning they have to have the same variable and the same exponent, right? Or the same variables, plural. Sometimes they have more than one variable, but they have to have the same variables with the same exponents to be like terms. So 6t to the eighth and 18t to the fifth are not like terms, so you cannot add nor subtract them. All right, number 28. So here, I'm still going to distribute. This time the monomials on the right side, no big deal. We can still just multiply it by each term on the inside of the parentheses. And so when I multiply 8cd squared by 3c squared d, I first start with the constants. 8 multiplied by 3 is 24. C by c squared is c to the third, right? 2 plus 1, don't forget about the invisible 1 there. And then the same thing with the d, right? There's an invisible 1 there, so when I multiply d to the first times d squared, I get d to the third. Okay? Alright, so now I'm going to multiply 8cd squared by negative, don't forget about the negative there, negative d cubed. So positive times negative is a negative. The 8 remains there. C doesn't change because there's no like base with C. And then d cubed multiplied by d squared is d to the fifth. All right, and then lastly, we're going to multiply 8cd by 1, positive 1. So anything multiplied by 1 is itself. So it's just going to be positive 8cd squared. All right, check to see if you have any like terms. In this case, we don't, right? We have a c and a d in each of these, but they all have different combinations of exponents, right? So that's our final answer. Next, let's look at number 30. So number 30, here we have a fraction 1/3. So remember, if we have an equation, we can get rid of a fraction, right? We can multiply everything by 3, but there's no equal sign, right? There's no equal sign anywhere in here. And so we don't have two sides to an equation that we can balance, by using our multiplication property of equality. So we're basically stuck with the fraction when we're working with expressions, right? But we'll see that won't be too big of a deal. We can definitely manage. So first, I'm going to distribute the monomial to each of the terms inside the parentheses. So each of the terms in the trinomial. So when I multiply negative 1/3 by negative 6, negative times a negative is a positive. 1/3 times 1/6 is 2, right? So 1/3 multiplied by 6. We have that 6 over 1. Remember, you multiply top times top, bottom times bottom. 6 divided by 3 is 2. Okay, then we multiply our m's. M squared multiplied by m to the first. That's going to be m to the third, right? 2 plus 1 is 3. So then I also have like bases with the n's. So I have n cubed times n squared. So we add those exponents. 3 plus 2 is 5. All right. So now we're going to do negative 1/3 m squared n cubed by positive 3mn. So negative multiplied by a positive is going to be a negative. 1/3 times 3 is just 1, right? And I could put a 1 there, but it's going to end up being an invisible 1 because there's other terms. So if there were nothing else there, I'd leave the 1. But since I'm going to have m and n, I'll leave the 1 out in this case. So m squared multiplied by m is going to be m cubed. N cubed multiplied by n is going to be n to the 4th, right? Because remember, we're adding these invisible ones. All right, and then remember, there's also an invisible one in front that I left out. All right, and then the last one will multiply negative 1/3 m squared n cubed by negative 12. So negative multiplied by negative is going to be positive. 1/3 of 12 is 4. Right? We can do the same thing here. 1/3 multiplied by 12 over 1. It's going to be 12 over 3, which equals 4. And then since we don't have any variables with the 12, our variable expression here is just going to remain the same, right? So it'll just be m squared n cubed. All right, no like terms. We don't have any common variable expressions, so that's as far as we can go.